Yeah, I guess people will just drop in whenever, and we are 10 minutes in, so let's do this. All right, so what's up, you guys? This is officially the start of the stream. We're gonna live code a little bit together, and I'm gonna be watching the chat. So if you have questions about what I'm doing or just on anything, you can put it in the chat, and I'll try to respond live. So let's do this. So here is the plan. The goal today is to make probably not an entire project, but a big portion of this. So basically, I'm going to use CDK and LanceDB and Lambda and S3 to index my LinkedIn posts and then maybe make a cool UI to search them. A lot of the times when I see people talk about this stack, they're talking about making like an LLM chatbot. And yeah, this could probably power an LLM chatbot, but I don't know. I just think LLMs are boring, and I don't really want to do that. So maybe we'll do that in like a future stream if people really want to. Okay, so the plan is we'll create an S3 bucket. So this is a bucket, and in that bucket, we will put a vector index containing all my LinkedIn posts. Vector index of LinkedIn posts, and then I wanted to make a vector database that I could query, but that I also could just leave up all the time and not get charged anything. Med, what's up? Thanks for joining. So yeah, vector databases are expensive. The pricing for AWS Elasticsearch, for example, pricing AWS OpenSearch. I'm assuming it's higher than $0 an hour if no one's hitting it. Oh, you pay for an EC2 instance. So you pay for an EC2 instance if you want to run OpenSearch. That's actually, I didn't realize they offered such low entry point pricing. It's literally just paying for a T3 small. And if you got this as a reserved instance, then, oh, do they not do small reserved? Oh, so if you get a reserved instance, I guess you have to start higher. That's lame. But yeah, dang. Elasticsearch isn't expensive as I thought, but still, 4 cents an hour is like $30 or so every month. That's still not free. I don't really want to. I want to be able to leave this up all the time. So my plan is, my thinking was I wanted to make some kind of server, like truly serverless, like scales to 0, totally free when you're not using it, vector index. And there's a pattern that people do with SQLite, where they'll just upload a SQLite database somewhere to S3, and then you can have as many REST API instances as you want that can do reads from the database. And the way that they do reads is they download the entire SQLite database and then run their SQL query against it. So this is the same idea, except it's a vector index instead of a SQLite database. So the idea here is that this is a REST API. It's a Lambda function. And basically this REST API reaches out to the bucket, grabs the index, and then it downloads fetch index. And it could do that. It could do that on startup. So cold starts will be slow, where like it has to download this whole index, and hopefully we can get the index to be fairly small. It'd be nice if it were, I don't know, under like 15 megabytes. So that might be aspirational. I've never made a vector index before, so I guess depending on how we do chunking and stuff, that may or may not be realistic. But anyway, if this is under like 15 megabytes, then the cold start time, this Lambda just has to download this 15 megabyte thing, and then subsequent invocations will be warm, and so we won't even have to download the thing. So I'm hoping that the queries are within like under a second for a warm start. Yeah. So I don't actually know how to use LanceDB. So I think what I'll start with is just getting the CDK project set up that creates the bucket and the REST API in a Python project. And then assuming that we actually get that far, which we might not if we get a bunch of questions, then we'll move on to the vector index. Otherwise, maybe we'll do like an episode 2 if people actually want that. All right, so CDK is awesome. It is a super great infrastructure as code tool. And to set it up, you have to set up like a full Python project. So I'm going to follow the instructions to do that. So AWS CDK setup. Actually, I already know how to do this. So I'll just do it and just do it from memory. I've got a terminal here. Go into my repos and make a new directory. Oh, I already have a directory, LinkedIn Post Explorer. Sweet. And we don't need any of this stuff. Yep. Yes. Okay, cool. That stuff's gone. Nice. Okay, we can What's the best way to do this? I have the CDK command already installed on my computer. You install with npm. You do npm install -g AWS CDK or something like that. You can also get it with Homebrew, but I think the best way to do it is with npm because CDK is actually written in TypeScript. Anyways, if you do CDK init, they'll bootstrap a boilerplate project for you. So I'm going to do language Python. And that should have created a bunch of stuff. So I'm going to open this up in my editor. I'm trying out Cursor. I don't know if I like it yet, but everyone's talking about Cursor. We'll see if it's better than VS Code in any way. Okay, cool. So this CDK init command just created all this boilerplate. So it gave me like a requirements txt with these two guys in it. These are two libraries you need for CDK. And it gave me an app.py file, which we can put our infrastructure as code in, and also another Python file to be like a helper module. So Julian, do it for CDK over Terraform? Yeah, I do. I saw a post on LinkedIn, and it was just like, friends don't let friends use Terraform. And like, you know what? Terraform is great. And I think Terraform has gotten even more mature over the years. But even I feel like to have an amazing experience with Terraform, like on a team, you have to buy a managed Terraform state backend merge. Yeah. Anyway, so I'll show you. How about this? I'll point out some cool things CDK has over Terraform out of the box as we go through this. Like one of the things it has is like a UI, and you can also write the infrastructure as Python, which that is a very nice thing by itself. But I would say I don't think Terraform is as powerful as CDK or Pulumi. So I feel like if you have the ability to write software, like you're not afraid of writing Python code, then I just think you should be using Pulumi or CDK because you like for more complex deployments, you can avoid like so much spaghetti code, infrastructure as code hell. So a lot of it actually just comes out of the fact that it uses a real programming language, which some people say is a drawback, but I don't know. When you see, I'll see if I can find a Medium article later that I can link. This guy has a decent opinion piece just bashing on Terraform. Let's see. So I like this boilerplate. Like they gave us the app.py, and I can never remember what to put for the requirements that they have here in the requirements txt, but I don't love this package layout. I actually have my own layout that I prefer to use when I'm starting a project from scratch. So I'm going to run and grab that. Let's see. This Cloud Course package cookie getter. This will work. So I made this template in the Udemy course called Taking Python to Production. And basically in the Udemy course, we set up a bunch of linters and all the code quality stuff that you'd normally use on a team if you're trying to manage the quality of your code on a team. Let's see, let's do CDK boilerplate. So throughout that course, basically, we build up to making one template. And so this is that template. So if I run these commands, it should install cookie cutter and then use the cookie cutter CLI to go and basically instantiate my project here. So let's see if this works. What? Why are there two characters here? Let's get rid of those. Oh, nice. Okay, cool. Let's call this LinkedIn Post Explorer. Oh, this is hard because I'm going to end up wanting two Python packages, one for the infrastructure as code and one for the REST API. Yeah, I'll maybe make two packages. I'll get to that. I'll make the second package later. This will be LinkedIn Post, Explorer IC. I'm wondering if it'd be better to prefix it. So I might regret this naming later, but let's do infra. Nice. And this will be, I'll just call this IC. Nice. Cool, we've got this folder, and this is more like it. This is the package layout that I really like. So it set us up for GitHub Actions and has some nice stuff for VS Code. It uses a source folder, and then it's got pre-commit and some linters and stuff all set up, and also a makefile. So I feel like this is just going to be easier to get started with. Anyway, so I'm going to go into the CDK boilerplate now and copy the boilerplate app.py that they gave us. This is how I always start a project when I'm working with CDK. Okay, got app.py, and then in this requirements txt, I'm going to take those requirements and put them in my PyProject.toml in the dependencies section. Let's see, can we wrap those? Nice. Sweet. Yeah, got our package. So let's try installing this now and see if that works. So in my makefile, I've got a wrapper around this script called run.sh. I really make as a task runner. Like you can use it to run commands. Let's see. Don't have any new questions. Okay, yeah. I really make as a task runner. Like it gives you auto completion for any commands that you have in there. So make install, I've got auto completion on this make install command, but I really don't like the scripting language in make files. And so there's a million task builder tools out there. The one that I've landed on, and the reason why I've landed on this is because I feel like for newcomers, this has the lowest learning curve. Because when people show up in a project, they recognize what a make file is. And so they intuitively know to go look in the make file to see what the project tasks are. But at the same time, I hate that make scripting language. Because for example, you can't set environment variables in like a sane way in make files, but you can in bash. So basically I have my make file wrap this bash script with a bunch of one-liners. And by the time you look at, if you look at the make file, then it'll be it won't be like a huge leap to see, oh, this is using this run.sh script. And then you can go here and then everyone knows bash. And if you really wanted to extend this, you could, because you could extend the bash script. Anyway, I'll do make install, and that should give me CDK and all this stuff. I finally have fast internet for the first time in my life, it feels. So now my installs go so much faster. Very cool. I'm going to also copy in this other boilerplate thing that they had. Basically, they gave us this app.py. The main thing to know right now is it imports the CDK library, and it creates a class called an app. An app is basically a set of stacks, and a stack is a set of like resources that we can create in AWS. But now that we have this app object, we can go and we can add stacks onto it. And later on, we're going to run this like a deploy operation against this app class. Wow, it's just really wanting me to install this extension. All right, cool. Maybe now it'll stop. Okay, so we're going to run like an install directive against, a deploy directive against this app. And any stacks that we've added onto the app are going to get deployed to AWS. What is this stack? It's a class that inherits from a CDK class called stack. The abstraction model won't matter a ton, but basically this is where I'm going to go and I'm going to fill this out and add resources, and that's how they're going to get created in AWS. So yeah, that's what we need to do. So let's see, so here in the source folder that was generated, there's a folder called IAC. This is our actual code that we can write and import. So the app.py, I'm not going to put in the source folder. And the reason why is because it's an entry point that, I don't know, it's meant to stand alone. I often see people put app. For example, in the boilerplate, they put app here at the root level instead of the inside. And the idea is the app.py should be so thin that you only need one file, and anything heavy or logical that it's doing, it should be able to do by importing stuff from this actual package that we have. So maybe the idea is this package is full of reusable stuff, and this app passes settings into instances of the modules that we make here in the reusable package. Anyway, I'm going to delete now the CDK boilerplate. I'll keep the CDK JSON just in case. This is a config file for CDK in general, and I rarely edit this, like really rarely. And I think it may even get generated if you don't have one every time you run the CDK deploy command. Anyway, this is, I also want their git ignore, actually. This would be good. Put that in our git ignore. Oh, do we not have one? Oh, okay. Let's put a git ignore here. Very nice. All right. So I'm going to open up this package in the root of our project. Git repo was found in the parent folders. It's lame that this package itself isn't a Git repo. Oh, we did have a git ignore? Wow, I'm blind. I did not see that. So this can be like CDK stuff. All right, I'm going to delete that. And I think for now, I'll just work from here. We won't make this a fully qualified Git repo. Okay, cool. So now I'm going to create a virtual environment and activate it. So yeah, we've got a virtual environment. Cool, nice. Now we can get moving. All right, so doing make install. How far in are we? We started like 20 minutes ago. So it took 20 minutes, but now I think we now have a good development environment set up. So I guess it always takes a lot of work to get boilerplate down. So it's really nice to have a templating tool like I showed you at the beginning to bootstrap a lot of that stuff. And I like my template better than the CDK template. And so maybe I should just make like a unified template that just already has my opinions and the CDK opinions. So in the future, if I wanted to do a CDK project, I could just cookie cut all this at once. But for our purposes right now, we have what we need. So, all right, let's do this. So I just installed the library. So am I getting syntax highlighting? Yeah, it looks like VS Code's recognizing, or cursor is recognizing the imports that we have. So that's awesome. Let's start super trivially and let's make an S3 bucket. To do that, every service in AWS has like its own submodule of CDK. So from AWS CDK, import AWS S3 as S3. Yep. This is like the standard import convention. Like they always do these they always like re-alias the modules and strip away the AWS part of the module. Anyway, whatever S3 code out there in the wild, that's what they do. So this is how we'll create a bucket. Like you just create an instance of a bucket and you give it a name. I could explain why we pass self in here, but I feel like we'd be going down a rabbit hole if we did that. I won't. I'm going to control the bucket name. Do I want to control the bucket name? Nah. If I don't pass in a bucket name, then AWS is just going to auto-generate one, and it'll be guaranteed to be unique, and it'll also be ugly, but I think that'll be fine. All right, so phase one complete. We have a boilerplate app. Phase two, let's do a trivial deployment to AWS. What I want to do for this trivial deployment is create an entire AWS account just for this video and do all of our deployments of that. And then one day when I take this down, I can just delete the entire account and clean up everything so there will be no side effects. So let's look at how to do that. So I'm going to go to my browser and I have this cool login page set up for AWS. Nice. So here is my root account. So in here, I'll go to AWS organizations, and that'll let me pretty quickly create a dedicated AWS account just for this. So I'm going to put it, I don't know, where should I put this? Probably just here at the root is fine. Okay, add AWS account. Look how easy it is to create an AWS account. All right, let's see. This is LinkedIn Post Explorer, and enter an email address of the account's owner. Oh man. All right. I guess I'll put in my actual email here. So if I'm not mistaken, I think these email addresses have to be unique. So what I'll do is add a plus sign in front of my regular email and then call it do plus LinkedIn Post Explorer. And this basically is an alias for my email. Any mail that gets sent to eric.rodock@gmail.com is going to get sent to eric.rodock plus LinkedIn Post Explorer. No, any mail sent to this whole long thing is actually just going to get sent to my email address. But as far as AWS is concerned, this is a unique email that I've never used before. So this saves me from having to go create like multiple Gmail accounts to have like a different organization owner. And I don't know, like maybe I don't need a unique email, but just in case, I don't want to run the risk of potentially wasting time. So let's just do that just in case and create the account. And creating the account is pretty fast. It says it's going to take a few minutes, but I've seen it take just like 20 seconds before. Anyway, while we're waiting for that, I'm going to open up IAM Identity Center. This is basically a centralized way to manage permissions for all your accounts. So I have a group called administrators that I'm in only. And I think all I have to do is add the new AWS account to this group, and then I'll be able to access it from this like centralized login page, which I have, which is pretty cool. So let's do that. Why? I always get lost in this UI. Where do you actually go and add? You might do it from the accounts UI. LinkedIn Post Explorer, assign users or groups. Okay, nice. I'll just give it to administrators. Sweet. These are permission sets. They're basically permission sets are essentially what they call IAM roles that can be activated in multiple accounts. It's not an exact definition, but I think that's a good way to think about them. It's IAM roles that can assign you different levels of permissions depending on which account you're in. I'll just give myself all of these permission sets. Next, submit your AWS account. Nice. All right, cool. So if I go here and I refresh, will I see my account? No way, look at that. Okay, so we have a brand new fresh AWS account just for this stream. Okay, Julian. CDK sounds great, by the way. Thanks for the explanation. Yeah, my explanation was very hand wavy, but maybe you'll just see and decide that you think it's great. Maybe it's not great for multi-cloud. Oh yeah, it's totally not great for multi-cloud. It's only AWS. So yeah, actually let me just show you this. So if you go to GitHub, AWS CDK GitHub, so they pushed out an insane number of commits. So here's like almost 15,000 commits now. Wow, I'm actually surprised. I normally see commits like within the last few minutes. So the fact that actually their most recent commit is Oh, here we go. There's one last week. I often see commits to CDK every hour, but maybe they've gotten so good that they don't need that anymore. So don't need to be modifying it that fast. Wow, 2.2K issues. Okay, cool. So then in contrast, there's Pulumi GitHub. Oh, are you saying on CDK? Did I miss that? Oh, 14 minutes ago. Okay, duh. Thank you. So yeah, you can usually find a pretty recent commit. Okay, so in contrast, Pulumi has 12,000. But it's like this IAC language that can work cross cloud, and it also has commits relatively frequently as well. Oh wow, the most recent Pulumi commit was last week, or 1 hour ago. Okay, yeah. So both projects are pushing commits pretty regularly, right? But CDK has more commits. I'm not saying the number of commits means I'm not saying more commits equals more maturity, but okay, CDK does have more commits, and Pulumi spans every single cloud. There's like GCP, Azure, Oracle, Alibaba, Hetzner, and then like third-party vendors like GitHub and Auth0. Like it doesn't have as much coverage as Terraform, but it has a lot of coverage cross-cloud. But these commits, they commit pretty much as often as CDK, but all the CDK commits are focused on AWS and AWS experiences, whereas Pulumi commits are like diluted across like whatever clouds they're supporting. And AWS has like an army of developers that use CDK. So CDK is like AWS's recommended language of choice. And the second there's a gap that affects the community, it gets patched in CDK. I guess that's not, people have complaints about some missing coverage in CDK, but basically it's AWS's blessed IAC language. And you feel that when you're using it on AWS. My opinion is you get the best infrastructure as code experience aside from the obvious glaring weaknesses of CDK, like it uses CloudFormation, so it's slow. But in general, like you can feel that AWS is the most supported thing. And so when you're working with AWS support or like integrating with AWS things, like you'll get the best AWS experience if you're using CDK. And CDK, it's a good infrastructure as code language. Unfortunately, it's slow and has some quirks to it. So I think that Pulumi may just be the best IAC language. And so I'd love to see the love that CDK gets actually just redirected here. But then the problem with Pulumi is like it can be self-hosted for free, but then you run into a lot of the same. You can self-host it for free, but I wouldn't do that. I wouldn't do that in like an enterprise situation. Working on a team at work, I'd be nervous to self-host Pulumi for anything that isn't trivial. Because if you mess it up, you'll lose your state and you might corrupt your deployments, and it could just be like state hell if you know about state in infrastructure as code tools. So Pulumi is probably the best from a feature standpoint and from a cross-cloud standpoint, but it costs money. They charge you hourly per resource. The free tier burns up after about 200 resources. So for the last team that I worked on, we could have gotten like two REST APIs out the door. We were doing like a new REST API every week or so. So we could have done maybe 2 REST APIs on the free tier, and then we would have been off, and then the pricing just gets out of control pretty fast. It's a powerful tool, so I guess I can see why they're charging so much for it, but it is, I don't know, for my own personal projects, and even for work, if I was only on AWS, I'd rather not add another contract that I have to go through procurement to get through. And I don't know, AWS's CDK is so powerful that I feel like you overlook its rough spots if you're only on AWS. All right. Anyway, so we have our new AWS account. That is so awesome. What I'm going to do now is get programmatic access to this account. And I didn't even have to log into the UI technically to do that, but I'm going to make a new AWS profile called LinkedIn. Man, I don't want it to be like a long name because I'm going to have to type it a bunch of times. LinkedIn post. I'll just do the whole thing. All right. LinkedIn Post Explorer. Cool. This command here. Let's see. MLOps Club. Oops. Let's try that again. There we go. This is cool. This command here just opens up the UI, and I can log in and allow access. And temporary credentials were just generated, or they're about to be generated when I pick an account. So I'm going to pick my LinkedIn Post Explorer account. So this view in the UI, this is like a terminal-based version of the central login page that I was just showing you. So super cool. I'll do this account and then choose administrator access, default region, US West 2, JSON. Cool. So yeah, now I have this profile that has like temporary credentials. So in about 2 hours, this profile is going to stop working. And if I wanted to use it again, I'd have to like re-log in. And that's intentional. That'll make it so that if anyone ever got my laptop, they would not ideally be able to get access to these administrator credentials that I just created. Nice. So now that we have this profile, let's see if we can deploy our S3 bucket to the cloud here. The way you use CDK is you execute the app.py, and the app.py, or sorry, not direct. You use the CDK command to do it. So I'll do CDK deploy, and then app, Python, app.py, region, US West 2, profile, our profile. CDK is written in TypeScript, so the CLI is written in TypeScript, but it's going to turn around and invoke this app.py. When it does that, the app.py is going to run this app.synth command. That's going to go through all these classes, and it's going to generate JSON files that are CloudFormation JSON files for any of the classes it finds here. And then right after it generates those files, it's going to submit all those to AWS CloudFormation. Let's try this. It shouldn't work. Oh man, I have an old version of Nodes. It's mad at me. Module not found, LinkedIn Post Explorer. Oh, that's right. I changed this to IC. Nice, okay. Okay, cool. So it at least executed the file. The error is telling me now, it wants me to do a process called bootstrapping the AWS account. So let's do that. CDK, bootstrap. I need the account ID for this account that I just created. So AWS STS, get caller identity, LinkedIn Post Explorer. Nice. So here's the account ID for the account that I'm working on right now. I'll paste this into this URI. Cool. So what this is going to do is it's going to create an S3 bucket and like a parameter and parameter store. Okay. Why did this fail? Failed bootstrapping. Need to perform AWS calls for this account. What the credentials are. Oh, wait. Did I not? Oh, duh. LinkedIn Posts Explorer. Nice, cool. The account's bootstrapped. So basically, this is going to create one stack in this region, US West 2, that I want to work in. So going to CloudFormation, CDK Toolkit, create in progress. Okay, so in this stack, there's not a lot of stuff. There's a role, there's a ECR repo, and this will become really handy if we use Docker. And there's a single SSM parameter, and there should also be a bucket. Yeah, and there's a bucket. Cool. Man, I don't know if it makes sense to explain this right now, but if you've used CloudFormation before, let's say that you have a CloudFormation template that's going to deploy a Docker container. CloudFormation is just a system where you can write a YAML file and define some resources and then submit that to AWS. So CloudFormation has no ability to build your Docker image from a Docker file and then push that to ECR and then deploy that image. If the image were already built and pushed to ECR, then it would have an ARN and the CloudFormation YAML file could reference it. But if you're wanting to work with a Docker image and you're working CloudFormation, it's on you to run a bunch of Docker build commands and stuff to build and push your Docker image to somewhere in ECR. CDK will actually do that building for us, like all in one command, like any like assets like Docker images or Lambda functions or whatever that have to be built locally and then uploaded before they can be referenced in infrastructure as code. CDK will actually build those for us. And what CDK will do is it'll upload them to like this staging ECR repo or the staging S3 bucket. So basically we've given ourselves a place in S3 to store like intermediate assets for any CDK deployments that we do going forward. Let's see. So we've got, I'm going to close this window. Cool. So we've been bootstrapped. So now, moment of truth, we're going to deploy our Python app to US West 2 using this profile. And because it's been bootstrapped, this time we shouldn't get an error. So fingers crossed. Let's see how this goes. Actually, for this moment, I do not want this node error. Let's get rid of this. The software is currently running node version 16. Here's a better version. All right, cool. NVM install. Let's grab like node version 18. Oh, it's already installed. Sweet. NVM use 18. NVM is like PyEnv. It's for Node.js unless you install and switch between versions. So if you haven't used Node.js before, but you have used PyEnv, just know that all interpreted languages have this problem of language version management. It's not just Python. All right, cool. So let's rerun that CDK command again. Oh, my stars. We didn't get a warning. So cool. Okay, so synthesis happened. So it took us 4 seconds to generate. There's this new folder here called CDK out. This folder was generated in that 4 seconds. And this JSON file was generated. This LinkedIn Post Explorer stack.template.json. This JSON file is a CloudFormation JSON file. And right now that file is getting deployed to AWS. Hey, very nice. Okay, so it looks like our stack was deployed. If I go to CloudFormation now, check it out. We have a new stack in here. And in that stack, under the resources tab, there is a bucket. There's a bucket. Sweet. Okay, here's this link, this physical ID link. If I click it, it takes us to the bucket. This is the randomly generated name that CDK generated for us. So yeah, super ugly, but at least it's unique. That's cool. Now that we have our bucket, let's do something way less trivial, and let's create our REST API, which is just going to be a Lambda function with a function URL. It is pretty cool how this works. What I am going to do is I need a Python package for our API. So what I'm thinking of right now is, should we make our Python package like a sibling folder to the CDK folder? I often do that, but I think I'll do it nested right now and just stay in this. So I'm going to do a folder called assets. And inside this assets folder, we'll do like a whole Python package. We'll call this, what should we call this? LinkedIn Post Explorer API. Cool. So in here, I'm going to copy all the boilerplate that we had for like our Python, just having a Python package. So there's some placeholder values that we're going to have to go change in a few different places. Okay, yeah, let's call this LinkedIn Post Explorer. Cool. So we don't need this file. So yeah, it's weird. We're making like a Python package in a Python package. We need to change this name in a few places. API, and maybe in run.sh. Oh, nice. Run.sh doesn't reference our package name at all. I think I did that intentionally to make it so there's fewer things that you'd have to change in different instances of the template. Oh, wait, but this is here. I see. This is the package name, so I got to just make this our new package name. Nice. Okay, so I think that was all the boilerplate we needed for our package. That was way more painless than earlier when we created this for CDK. Cool. So in here, we need to make our REST API. So I'm going to make a super trivial Lambda function handler right now. And let's just see if we can get that Lambda handler to be deployed to AWS. And then we'll add complexity from there. AWS Lambda handler.py and like function handler event context. And I'll do a print statement too, just so we have something coming out so we can validate this works. This is all you need for a trivial Lambda function. The reason why I added all this boilerplate is because eventually we're going to want to add like dependencies to this. And so there'll be a PyProject.toml. So like a trivial Lambda function can literally be a single Python file. You upload to AWS if that's your code. But like I want a first-class Python package development experience with this Lambda function, and hence adding all these other boilerplate files. So the value of adding something like a PyProject.toml is going to become more apparent as we go. But among other things, it can let us generate Lockfiles and add complex dependencies and cool stuff like that. Now that I have this handler, I'm so excited to use this. Okay, CDK, similar to Terraform and Pulumi, it has the concepts of reusable modules. So if I wanted to right now to deploy this function, I could come to my stack here and I could say like from AWS CDK, import AWS Lambda. And so here I could use this library to create like a Lambda function. And this construct, this module to create a Lambda function takes a lot of different arguments. Did I just change my keyboard? Let's see here. Oh man, what? Why is my autocompletion not working? Okay, this takes a ton of different arguments here. Bunch of different arguments that you can use to configure a Lambda function. I don't really want to have to mess with configuring all these arguments right now. And this construct is like very generic. You can use this Lambda function construct /class to create Python Lambda functions and Node.js Lambda functions, and I think Go and Java Lambda functions. It's very general. And so there's a lot of arguments that I'm going to have to put into this that are just boilerplate, just to make it a Python function in general. There's a more opinionated class that's just for Python functions, Lambda Python. And it is pretty amazing. So in 5 lines of code, you can get like a sick Lambda function setup that I think this even puts your Python dependencies like in a separate layer. It'll do this Docker process to pip install your dependencies and zip them up and upload everything to S3. My hope is that we can use this construct here to save us like a lot of the boilerplate to get like a really like premium Lambda development experience. This uses TypeScript because CDK is written in TypeScript, but all the classes in the TypeScript version of CDK have Python bindings for them that have been generated that do the same things. So the TypeScript docs are as good as the Python docs because the bindings are literally one-for-one parity. Let's see. Is there any way to slim our Lambda if we have huge dependencies? Yes, actually, the PyProject.toml will help with that. Like, it'll make it so that we can have, like, if we have dev dependencies, like linters and stuff that we don't want to end up Lambda code, we can use the PyProject.toml to like separate out different categories of dependencies, and then we can make it so that we install only the required dependencies, like just basically required dependencies only. Anyway, cool. Let's do this from AWS. So yeah, from AWS CDK. This is the one thing is this is considered an alpha construct. So can we just, I may actually have to like pip install this like separate thing. Let's see. Can we just import this? AWS Lambda. Yeah, this module is still in like alpha. Like CDK, I think they may have an independent semantic versioning scheme for like different modules. And some modules, like this opinionated Python module, maybe they're still like solidifying the interface. And so they have an alpha and beta and production phase. I actually think it's just alpha and release life cycle that they put all of their opinionated infrastructure as code modules through. It might put you off to see that this Python Lambda function is like still in alpha. So theoretically it could have breaking changes rolled out to it. But it's been in alpha for years, and I have code that I've written with this construct from long ago that still works today. So I don't know why it's still at alpha because they don't seem to be changing it that often. Anyway, I think I can just pip install this, and it will get us. Okay, yeah, that installed us the package. So knowing that's a correct import install statement, I'm going to add that to our dependencies in the upper PyProject toml. Cool. Now in the future, we'll get this module all at once. How are we doing on time? Nice. We're under an hour in. So yeah, we're totally going to get this Lambda function deployed, which will be sweet. All right. Did this work? Oh, why? Why is this not working? Let's see. Lambda. Let's see. Let's go to they also generate a Python version of this docs. I just find them uglier because they're using like the old Sphinx theme, the read the docs Sphinx theme. So I actually just prefer to read the TypeScript docs. But yeah, do they have an example of their import statement here? No. So we just have to guess what it is. That sucks. Let's see, Python. Let's just try doing this. There we go. This can be learn a Python. So does this crash our program? No. It doesn't. So I think that's valid. Man, why am I not getting auto completion? That's not good. Pip list. Yeah, we have this module installed. That's good. Which Python? My interpreter is currently the LinkedIn Post Explorer one. Let's try doing reload window. It's not going to be cool to develop without this auto completion. All right. Do you want to install the recommended extensions? No. Oh, good. It's green now. All we needed was a good old reload window. All right, cool. This is going to be so great. I won't show you this right now, but the equivalent of this that I've done in the past takes probably 70 lines of boilerplate to get a nice Python Lambda experience. So if this works with 4 lines, like with these 4 arguments here, I will be so happy. All right, let's let autocomplete put these things in for us. For every time you make a construct, you got to pass in self. The reason for that is pretty cool. It has to do with the way that the CDK library is designed, and I love it, but we should talk about that. You also have to give a logical ID to every resource in your stack. So that's this. And this ID has to be unique to all other IDs passed in all other resources in this CDK app. Okay, so I believe that for the entry, yeah, we just need to pass in a path to the source folder here to tell Lambda where to go get our code. Yeah, app.py is a sibling of assets, so that should be good. And then our index file is AWS Lambda handler. Oops. And then the handler itself is a function called handler. Let's go check that. Yep, called handler. Cool. Is this going to work? Let's try deploying this. All right, Python function, missing one keyword argument runtime. Oh, I think it wants us to pin the Python version that we're using. Come on. Do we have a special? No. All right. I think we have to grab this out of the Lambda library itself. So from AWS, oh wait, we already have Lambda. Cool. So they have this enum. We can choose what version of Python it's going to be. So yeah, Python 3.12, sweet. I actually had issues with Python 3.12 on Lambda the other day. So just to be safe, I'm going to go 3.11. What version am I using? Python version. Yeah, I'm using 3.11 locally for this exact reason, because the other day I had an issue with 3.12. All right, so let's try deploying that now. All right, what do we got? Cannot find index file. Oh, interesting. Oh, because it's an IAC handler. No, it's not. It's in LinkedIn Post Explorer. What have we got? So we're getting an error, and the error has to do with Docker, which is great because it's trying to use Docker. Is it because I don't have Docker running? Okay, I will say this is one issue with CDK. The error messages can be nasty, and the reason why is because we're literally running Node.js right now. If I drill into this S3 bucket class, if I want to see the implementation of this class, cool, yeah, there's tons of arguments, that's great. But if we go to see the actual logic in here, we create this thing called bucket props, awesome. And then there's only a single function call in this class, and it calls something called the JSII. The JSII is the JavaScript interpreter interface or something. It's a project created by AWS specifically for CDK. And it is this tool that they use they write a bunch of classes in TypeScript, and they generate bindings for those classes in Python, Go, Java. And when you run those classes in the bindings, they literally just turn around and call the JSII again, and then they just invoke the Node.js version. So you're actually invoking Node.js. So when you get an error deep in CDK, the stack trace leads you into Node.js, and that's why. Actually, I'm not seeing any references to I'm not seeing any Node.js bits of the stack trace, but it does happen sometimes. But let's see. Oh, thank you, Mark. JavaScript interface. So it is a cool concept. It's super slow. It is so slow, and the thinking behind that was like there wasn't a need to make it fast because infrastructure as code is just a bunch of config files. It's not like we're using CDK inside of a REST API, which, by the way, there's reasons you might want to do that. But anyway, the thinking is it doesn't have to be super fast. Okay, our issue here, by the way, is that the Docker's not running, so I'm just going to start up Docker. Infrastructure as code doesn't have to be fast. It's basically glorified. It's a way to generate config files, really. So let's start running this again. And so because that wasn't a concern, they created this JSII interface, and it's super slow and really annoying to debug. But it does make it so you can write infrastructure as code modules once and then vend them in all the languages that people often want to use infrastructure as code in. So that's pretty cool. But in order to do that, the JSII was built, like the reason it's called the JavaScript interop interface is because it's to make other languages interoperate with JavaScript. So if you want to write an infrastructure as code module once and then vend it to all the other languages, you have to write it in TypeScript. And then bindings in Python can be generated in TypeScript. So that's lame because I think Python is just a more fun. I just think it's weird to me that like TypeScript has actually eaten the infrastructure as code world. Like I think you get the best experience both on Pulumi and CDK if you use TypeScript. And there's another framework called Serverless Stack, which is really nice. SST. This actually, it used to wrap CDK, now it wraps Pulumi. But it gives you like all these quality of life improvements, like hot reloading Lambda functions and stuff. Quality of life improvements over like CDK library. So it's basically a framework. It used to be a framework over CDK, now it's a framework over Pulumi. And yeah, it's TypeScript only. So it's just crazy that the infrastructure as code world has been taken by TypeScript. Okay, this is really cool. It does want to deploy my stack, but before it does that, it shows me a diff of everything that would be created or deleted or modified. And so this report is awesome. My stack could be super complex, and the change I make in my code might not be might be hard to reason about. If I change one setting, it might have a blast radius of changing like many different resources. So this report tells me all the things that will actually be changed. And so in the CI/CD setup, like for PRs, you can, as part of the PR process, you can generate this report and you can have your reviewers review like what changes this would make to your stack. And so you can use this as a basis to decide if you actually like the changes or not. So basically this is the same thing as Terraform plan, or I think it's Pulumi plan as well. Yeah, all the IAC tools have a subcommand to generate this report. And I happen to really like the format that CDK gives it to you in. Okay, so basically what this is going to do is it's going to create an IAM statement. So they have a whole category just for permissions, because permissions can be like a way that security vulnerabilities get introduced. So they have a whole section of their report just for like permission related changes. And then they'd have a different section for like vanilla resources like S3 buckets and stuff. Anyway, so cool. We're apparently going to be granting Lambda, the service, ability to assume a role. So great. And that role is going to have this policy Lambda basic execution role. So basically we're apparently by creating this Lambda function, we also created an IAM role that allows Lambda to invoke our Lambda function, which is sweet. Like it's a whole resource that we didn't have to create and configure ourselves. So yeah, say yes to this. And this is generating a CloudFormation change set. So it's calculating like what things actually would need to be changed in AWS. And it's pushing those updates to our stack, which is so awesome. I'm gonna go look at the generated CloudFormation JSON because I want to give you a sense of how much work this Python Lambda construct is doing for us. Okay, cool. Oh, it deployed successfully. That's so great. Okay, look at this file. Let's go to the resources section. So we're creating a bucket, and that was our code. We did that, but we're also creating a service role. That's cool. We're also creating the Lambda function itself. So yeah, I guess you might have thought that we were only creating a Lambda function, but I guess we're creating this additional resource too. And that's the magic of infrastructure's code modules is it'll create or modify whatever it takes for the whole module to work. And so like basically the fact that we need this IAM role with this very specific policy, like this is boilerplate that we would have had to have added ourselves. And it's just taken care of for us, which is so sick. Cool. So let's go try invoking our Lambda function from the console. Watch the, okay, yeah, I'll start the console first. So here's our stack, go to resources, refresh this, flat view. Okay, here's our Lambda function that we just created. Let's see, so if I go to test, hey, there's our code. That's cool. That is so cool. All right, let's invoke this. Nice, it printed out our thing. So it all works. That is so sick. Okay, let's add a dependency to this. I'm gonna add FastAPI. Let's see. So I'm gonna go to the PyProject.toml of the Lambda function. And in the dependencies, I will add FastAPI Slim. There was a recent update to FastAPI where they created like a FastAPI like CLI, which is pretty cool, but it installs like really common libraries that like bloats your project. So like now if you want to install like the slimmest version, you got to use FastAPI Slim. Anyway, yeah, let's do this. So now what's cool is if I do if I do this CDK deploy command right now, so I just added this new dependency, the construct should actually install the dependencies. Oh, we don't want CDK. Oh, and since we didn't see CDK before, that means I think our installation setup is not working. So I think I just need to make a slight change to this file. So here in the entry, we gave it a path to source. I'm not going to give it a path to source. I'll put the source path here. So now this entry, in the entry, CDK should find a PyProject.toml. I think that CDK is configured to look in this path and see if there's a PyProject.toml or a requirements.txt, and if they're present, then it installs them. So if I did this right, then it should pip install stuff. Dang it, that was really fast. I'm not convinced that it actually installed anything. It did copy in the PyProject.toml. I'm not convinced it actually installed anything. But the deployment's done, so we can check. So the Lambda UI is weird. To refresh the code view, you have to leave and come back. So I don't see our dependencies here. And now we have all this junk that we don't need inside our Lambda function, which isn't good. We don't have a layer. Okay, so our dependencies aren't making it inside. That's a bummer. That's actually a huge bummer. Let's look at the docs for this and see if we can get those dependencies in there. Rahul, what's up? Let's see. The goal right now is I want FastAPI to be installed into our Lambda function. And so we need to make sure that FastAPI does get installed and then zipped up, then uploaded to AWS, going there with it. Okay, if requirements.txt, pip file, or poetry.log exists, poetry.lock. Oh, I don't want to make a poetry.lock. That's lame. And like the versions of dependencies on my Mac. Let's see, Rahul. Your course helped me a lot. And no, wait, dude, that's sick. Congratulations. That's awesome. flip, because if I generate a log file on my Mac, there's not a guarantee that log file is going to work on Lambda. I'm sure it'll work right now because FastAPI is mostly pure Python. It may be entirely pure Python. I'd have to double check. I think I would be surprised if Starla didn't use C or C++. But I don't like this workflow. The only way to get a requirements like a log file that you know that is guaranteed to work in Lambda or anywhere is to create that log file in the same OS. So basically create the log file with something like Docker. So I think that's a weakness of this construct, is they're not just going to pip install PyProject.toml file directly. But that's okay. We can create a log file. It's not a huge deal. And I guess this is a cool chance for me to show you a tool called PipTools if you haven't seen it before. PipTools will let us run a command called pipcompile, which will create a log file from our PyProject.toml. In fact, UV claims to have implemented this. Let's try UV. Okay, I don't have it in this environment. Okay. Pip install UV. If you don't know, UV is like this fancy alternative to pip that the same guys who built Rough are making. And LinkedIn is full of people who ask, like, why are you not using UV? And the answer is because it's still really new. It's not actually mature. And it's actually not fully backwards compatible with pip. And they are doing that by design. So like pip, for example, accepts certain environment variables and it accepts certain like config files. So those config files and environment variables, that pip has been configured with to use, they are the current industry standard. So things like AWS and Docker and build tool chains and stuff, like they were all designed around pip. And so yeah, UV is potentially way faster, but it also potentially isn't compatible with like different deploy and build systems. And so if you use UV, you're signing up for a future where you don't actually know if a given tool that you're going to use works with your installation libraries. Anyway, until UV becomes more mainstream and maybe adds some of the features that pip has today, I don't think it's going to be like mainstream and adopted by AWS and all the platforms. I guess that was circular. If it becomes standard, it will be adopted by the platforms. If it becomes adopted by the platforms, it's more likely it'll become standard. So there's a chicken and egg. There's like a cold start problem with any new tooling thing like UV. So it's great, shiny, but wouldn't standardize build pipelines on it quite yet, personally. Okay, let's make a requirements txt. Let's see, UV pip compile. Is that a thing? Yes, that's so cool. All right, watch this. If I go to assets and then API, API, yep. UV pip compile PyProject.toml. This should take my PyProject.toml and it just generated this. It generated a log file from the PyProject.toml. Isn't that so cool? So I have a bunch of stuff in my virtual environment right now. So doing pip freeze, that would give me like way more stuff in my Lambda than I need, because I'm like mixing CDK and FastAPI. Anyway, so this allows me to just get the dependencies and the transitive dependencies and so on from the one PyProject.toml file, which is just so cool. Let's see. So I guess I need to pipe that into requirements txt. Yeah. I usually like to name it like requirements.lock.txt or something, but I think CDK is looking for a very specific file name, so I think we'll just have to call it requirements txt. Oh man, but I love this. Look, Pydantic, it's telling us that it's a dependency of FastAPI, and so it's installing it. Like, I think it's also a direct dependency of our app, but yeah, maybe it's telling us both. I think it's saying both of these use it. So that's cool. Because like I didn't explicitly add IDNA to our project, so I might not have known where that came from. Apparently it's coming from any IO. I didn't add any IO to our project. Apparently that comes from Starlet. I happen to know that Starlet comes from FastAPI. So it's just like the fact that it gives you the traceability of dependencies, like I just absolutely love that. So let's go back and then rerun our CDK command. And maybe we'll actually get some dependencies this time. Dude, Ro, thanks for saying that. Sorry, it's taking me a while to I'm getting distracted. It's taking me a while to look at the chat. Is anyone watching Lost? Did anyone join? It doesn't know what we're doing. Oh, this is so sick. It installed the dependencies. Okay, that's way cool. It is healthy that they forced us to have a lock file. That's actually a healthy thing they're having us do. Because I am often guilty of not creating lock files for my projects. I get bit by it. I never learn. I come back to projects all the time and can't get them to run, and I'm so mad at myself for not pitting them. A pip freeze will do, but I think a really nice workflow would be like have Docker. Raul, join late. That's what's happening. Yeah. So Raul, basically, this should be pretty quick to summarize. So we're making a REST API on AWS that runs in an AWS Lambda function. So right now we're creating a Lambda function. That REST API is going to reach out to an S3 bucket and grab a single file. It's going to download one file out of that S3 bucket. And that file is going to be a vector index with all of my LinkedIn posts that I've ever made, which I have as a JSON. And anyway, so then you'll be able to run queries by hitting the REST API and search for LinkedIn posts is the idea. In the future, this could power a chatbot or something, but it won't right now. It's just going to be, it's basically going to be fancy full text search plus like attribute search or my LinkedIn posts. I don't know if it'll work, but also I've seen a lot of people use AI generative tools to generate an entire website. And so I'm hoping that at the end of this, I can pass in the API contract of this API that we're creating. And I'm hoping that if I give that to ChatGPT, then ChatGPT can generate as the cool front end to browse my LinkedIn posts and search them based on different criteria. So, Mert, but he hates chatbots. Yeah, I don't know. I just think they're overrated. Like with a chatbot, you don't really know what actions you have available to you, like with agents and stuff. But with a UI, you can see the buttons and drop downs that you have. So I don't know. I just think, at least right now, the way that I see a lot of people make chatbots is overrated. In my opinion, it's just my opinion. Let's see. So yeah, anyway, so to make this thing, we are using an infrastructure as code tool called CDK. And so we did a whole bunch of stuff to get CDK boilerplate together, but the actual code we wrote is like super minimal. It's so minimal. This file is what we've written so far. This script is creating an S3 bucket, and it's also creating a Python Lambda function. And we just did a fancy thing to make it so that our requirements are installed into this function when we run it. And so now all we have to do is develop on this handler file, and basically we'll add our API here, and then our API will be deployed as a Lambda AWS. Oh, really helpful for me then, because I am working on a chatbot. Nice. Yeah, if you're working on a chatbot and you want it to be powered by like an API, like absolutely, this architecture will work great. And honestly, I bet that in a future stream, we're going to build a chatbot on top of this. All right, cool. Let's take a look at the Lambda function that was deployed. Oh, my stars. Okay, good. Get out of here, go back into the function. Oh my goodness. It installed all of our dependencies into the code itself. It's not using layers. I don't like that. Let's even get our code into a layer. I think that I really want to do that. I think there might be a really easy way to do that with this construct here. Layer, Python function, packaging. Yeah, layer. Okay, sweet. Oh, this is going to be so easy. Wow. That's insanely easy. Holy cow. This would have been like 30 lines of boilerplate, but now they have it down to 1. Oh yeah, that's so sick. Okay, cool. So let's try this. Python layer version is what it's called. Yeah, Python layer version. Let's go here to our IAC. Okay. So here I'm going to create a layer. Lambda Python layer version. Nice. And then all we have to do is pass in this entry, and the dependencies are going to get installed in there. And I wonder, is there a way we can disable this, including our dependencies then? I think I'm just going to go back to having the source folder here. So now this is not going to find our requirements txt. And so it shouldn't install anything. So the Python function code should have just our code, but then this thing will find our requirements txt and install them and add our dependencies as like a separate layer. So that'll make it so that deploys are faster because we're not going to have to rebuild this layer every time. And it's also going to make it so that we can see our code in the UI. And honestly, I think I'll just do this in line. Layers equals this, and then let's see if we can get a deploy going with that. Mert. Oh man, yeah, you always have to pass in self and an ID. So let's do that. What the heck? Why are we back to a dumb Node version? I'm in the wrong terminal. All right. I don't know what the equivalent of pyenv global is for NVM. If someone knows, if you want to put it in the chat. I just use NVM use 18. And so only this terminal has Node version 18 now. Anyway, Python, okay, CDK. Deploy this thing. So while this is deploying, let's talk about CDK for a sec. CloudFormation is the infrastructure as code engine that CDK is built on. And so I'm in the CloudFormation section of the UI right now. And it's nice. I can see all the stacks that are deployed into a region. And in those stacks, I can see my resources. which is great. This is a really nice thing. It's a really nice thing that there is a UI that shows us our stacks, that shows us all of our resources in one place. Terraform doesn't have this. It does not have a UI. There might be ways to deploy a UI for Terraform, maybe like an open source one. And definitely, I think if you buy like the if you get like an enterprise contract with HashiCorp, then you can get a UI managed by them. But then you have to pay just to have this UI, which is a feature that CDK just gives you for free. Like you could easily find yourself paying in a contract with HashiCorp, like in the 20K or more a year, like a 20K year contract. Which, and I'm not saying that's a bad tool. It's just really annoying to have to spend that much money just to like be able to create resources and have a catalog of all of them in AWS. So I don't like that. So also with Terraform, if you don't pay for the hosted version, if two people go to deploy a stack at the same time, if you set it up wrong, then those two concurrent deploys could mangle each other and just break your stack. And if your stack is like really sensitive, like a very important production database, and you mangle that stack, like the consequences could be catastrophic. You lose all your data in your database. And it could be worse if you have a bunch of interdependent stacks and you mangle one, then maybe you actually just broke all of them and have to find the dependency relationship between them and go through each resource one by one and fix it. It can be hell. It can be infrastructure as code dependency hell. And so a UI is really important, and also a locking mechanism is really important that makes it so that only one deploy can go through at a time. And also a rollback mechanism is really important. If a deploy fails midway, it's really important to be able to roll back to the previous state that was working, and Terraform struggles with that immensely. Failed deploys midway in Terraform is a huge problem. CloudFormation, like for all of its flaws, which it has flaws. It has a limit of resources you can put in a stack. The stacks that you create are slow. Yeah, it's not everyone's favorite infrastructure as code tool, but it gives you all these enterprise features for free. And it's also this tool that AWS is just pouring resources into. Yeah, so because of all these reasons, in my opinion, you have to have a strong reason not to use CDK. You should use CDK unless you have a strong reason not to. And there are reasons not to, like if you need multi-cloud or something. But just, for the Pulumi and Terraform fanboys out there, I agree. I love those tools. I think it's great that they're open source. But if you want a enterprise-ready collaboration setup for your infrastructure as code tool, those tools are going to require you to pay tens, maybe even hundreds of thousands of dollars a year. Like Pulumi bills you per hour per resource that you create. On the team I was just on, we had thousands and thousands of resources. If we were billed for all those resources hourly, we would have had to pay their like. When you get a contract with Pulumi, you negotiate a price per hour per resource, and presumably that price in their enterprise plan is higher than what they list on their website. And so, yeah, I could easily see that for our use case where we were like trying to rapidly prototype stuff and we were deploying resources to AWS all the time, like we easily, I'm sure we could have gone into the 70K plus just on Pulumi spend alone, which is just so silly because like, you're already paying for those resources in the first place. If you're creating an S3 bucket, you're paying for the storage of the stuff in that bucket. And if you're running Docker containers, you're paying for the compute. And now you're telling me that you have to add like the 70K whatever fee on top of all that. It's a huge ask. Great tool, but it's just expensive. It's just expensive. Let's see. What's going on here? So we have an error. Seems like it failed to build the error. This is the layer. Why did it fail? Python VN failed to solve, blah, 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 blah. Oh my gosh, it failed to solve the requirements TXT. This is what I was talking about. Oh my goodness. It's already happening. I said that if you create a Lockfile if I create it on my Mac, it's not guaranteed to be resolvable in Lambda, and that's already proven to be true. It's in the Lambda OS, it's not able to install the versions of these dependencies that were pinned on my Mac. We're gonna have to go hardcore with Docker right now to generate a Lambda file requirements TXT that's like compatible with Lambda. Let's go do that. It's not going to be, I don't think it's going to be a huge deal. Yeah, I don't think it'll be a huge deal. In fact, I bet we can use ChatGPT to help us. Also, why is it using Python 3.7? I have to configure the Python version here, probably in the layer. No, what is this? Bundling, compatible architectures, compatible runtimes, layer version name. Oh man, in order to make this use Python 3.11, I'm going to have to pass in this bundling argument, and I think this can add up to a lot of boilerplate sometimes. Pretty please have a Python version. That would be so good. Is there like a special bundling options that's opinionated for this Python thing? Let's see, bundling. There's not. That's so sad. I wonder if we say compatible runtimes, will it use only Python 3.7 is supported? No way. No way. Because I think Python 3.7, I think it's already, I think support has already been dropped for 3.7. So it's just that'd be so lame if that were the only version that's supported. All right, maybe I can use my AI feature to take some of the edge off this. Use public ECR 3.11 to bundle this and install the requirement. Yeah, to bundle this layer by installing the dependencies in requirements txt. So this isn't fixing the invalid Lockfile, but it's at least going to make it so that we're using Python 3.11 when we're installing the Lockfile. This looks right to me. This does look right to me. It's using bash, it's doing pip install requirements txt, it's installing all those things into a folder called asset output Python. Yeah, this does seem like it would work. Oh man, no, this isn't real. This might work. I hope that works. Okay. This is really complicated here. The goal is we want to pip install our requirements txt and zip it up. But doing that on my Mac won't work because my Mac has a different OS than what's running in Lambda. So we need to use Docker to virtualize. It's not technically virtualizing, but functionally we're using Docker to virtualize, like simulate a Lambda environment. And we'll run the pip install inside this Docker container. And the Docker container we're using, by the way, is this public ECR Lambda Python 3.11 one. This is a Docker container that is published by AWS on their private registry. And it perfectly simulates the Lambda runtime and like Lambda OS, the OS that Lambda is running on. And so any commands that we run in here will basically be running on a Lambda compatible Docker environment. And so if we do our pip install in there, then the zipped up dependencies and whatever C dependencies they have will be compiled correctly for the Lambda architecture. So this whole complex thing to create our layer is using Docker, and it's using Docker to get like a perfect install of our requirements txt. Later on, I'm going to use the same image to also generate the requirements file as well. So the requirements file is generated for Lambda and then also installed for Lambda. Basically, the way this works is CDK is going to start up a container from this image. It's going to run this command, and asset output is going to be mounted to a volume in this Docker container on my host machine in a very particular place. So when these requirements get pip installed, they'll land in a place on my machine that CDK expects. So then CDK will be able to grab those pip install requirements and upload them to S3 as a layer. So it's complicated, but it's going to be a nice experience for us because all we have to do is run CDK deploy. All that stuff just happens for us. Like the Docker gets started, the things get installed. All right, let's see. Oh man, are we going to be messing with options for a while? Okay, so it doesn't like bundling options. If anyone's watching and wants to like put their opinions on what we should do to resolve the error, I would welcome it. Usually it's a typing issue. CDK can be really particular about the types that you pass into things. So it may just be that it doesn't like that I pass a string here. So in the image argument, yeah, it wants a Docker image thing. So let's go grab that. It's not very Pythonic in that way. Like usually in Python, if you pass like a string, pass in the intuitive thing, like behind the scenes, Python code will figure out what it should be. Like if you're writing a good library, but that's okay. That is okay. Import AWS CDK as CDK. Oh no. All right. So CDK, I think it's assets. Oh man. Maybe AI can do this for us. Generating. Awesome. Accept. So yeah, this should, oh, what the heck? No. This would be building the image ourselves. We don't want to build the image. We just want to reference it. All right. This AI is pretty dumb. It's not. Can you get a? Oh, I should check LinkedIn. There might be people who were confused and couldn't get on the stream. Darn, looks like that did happen. All right. So, oh no, it does say that there's a CDK Docker image. Oh, my auto-completion just wasn't. Dang, that's such an auto-completion fail because I checked the CDK module earlier. CDK.Docker image. Yep. From registry. Nice. Paste that. Oh, shoot. public ECR, hopefully that is right. So let's start deploying this. And hopefully we'll get the same error we had before where it just can't resolve our log file. The reason it's taking so long to do anything right now is because it's doing all that Docker stuff and it's not giving us the logs real time. Okay, here we go. Okay, cool. It pulled an image. That's great. Entry point requires handler to be the first argument. What are you talking about? What? Oh my goodness. Why? That was the reason it failed? Oh, I know why. I know why. This is the actual Docker command used for running Lambda. And when this image, when the image starts up, it was passing my command to a pre-existing command in the Docker image that's meant to invoke the Lambda function. So I need to make the entry point to this thing just bash. So that would be, are we here? I don't know. Okay, good. There is an entry point thing. Cool, we're good. Bash. And I guess they want a list of strings. Honestly, we could just change this to entry point. This is Docker stuff. This is all, it's deep Docker stuff. So I wouldn't expect you to really get what's going on here unless you knew Docker. And then on top of being Docker stuff, it's CDK's opinionated way of pulling and running Docker containers. So there's two learning curves to understand what we're doing here. But it's worth understanding because the end result is you can just do one command. It just pulls, builds, pushes. Okay. Hey, nice. And so I think we're back to the era of not resolving the requirements txt. Sick. All right. Unfortunately, honestly, maybe CDK can generate the requirements txt for us. That would be so cool. I think in the construct, there's this concept of setup commands, linting, for example. Okay, cool. Before bundling, run PyTest. I wonder if we could generate the requirements txt from like all using CDK. That might be bad though. I don't really you want to always be updating your log file all the time. I think actually I think what I just said is I don't want the generation of the log file to be coupled with deployments. So let's go do a thing then to generate a better log file. In this run.sh, I'll add a new function. I have it set up so functions become commands. So let's do generate log file. So which UV or pip install upgrade UV, and then that project.toml. Oh, so this is what would work normally to generate the file, but obviously I can't just run it on my Mac or it's not going to work. So we're actually going to have to use Docker to do this. So using the public ECR, AWS, Lambda 3.11 image to generate the log file in the correct target architecture and OS. Please run this in Docker and mount a volume with pwd such that the requirements txt ends up in my directory. Let's see here. Docker run. This looks fantastic. It's going to mount my folder in as a volume. The working directory is going to be app. Okay, also fantastic. Use the long version of the Docker CLI arguments. Okay, so then it's going to run bin bash. Oh, we also need the entry. We need the entry point to be bin bash because otherwise we're going to get the same issue we got earlier. But then, yeah, it does pip install UV and pip compile. So that should work. Yeah, that should work. Okay, cool. Good. I can edit the entry point manually, so I'll just do that. This is a disappointing amount of boilerplate. I'm sure there's a better way to do this with CDK more directly. But yeah, it's not the experience I would have hoped for. Let's see, with this construct that's supposed to make like Python development really easy. All right, so let's make the entry point. Cool. Yeah, let's try this. Let's do cd assets, cd API, bash run sh, generate log file. By the way, I'm going to go till, I guess, 10 minutes from now. So we'll see how far we can get in the next 10 minutes. So hopefully we end in the next 10 minutes with a boilerplate FastAPI app and Lambda, which would be I think that'd be a pretty good progress, like pretty good milestone. Oh, UV didn't like this. Maybe it needs that. Is it really updating requirements txt? I just want to delete that and prove that's actually doing what it says it's doing. It's not. Oh wait, no, it is. Okay, we just generated a requirements txt in a Lambda Docker container. So now it should work in Lambda. So I'm gonna make a new terminal. NVM use 18. Cool. And then CDK and all that stuff. It would be so sick if this actually installs our requirements. Okay, what happened? This Lambda function uses a runtime that is incompatible with this layer. That's not technically true, but CDK thinks that's true because we have to explicitly declare which Python runtimes this layer is usable for. So we said that our Lambda function is going to use Python 3.11. So we have to declare that our layer is specifically built for Python 3.11 because this layer doesn't inherently know what versions of Python it's compatible with. Like it doesn't, there's nowhere in this config directly that we said we were using Python 3.11. We pass that as the string, and this string could be anything. Wait, oh my stars, how do we, runtimes. I really hope this is like a real way to do it. No, oh, because it's an argument to the layer itself, not to bundling. Good. Hey, check it out. Yeah, nice. So it actually resolved it. It totally resolved the Lockfile. That's so great. Okay, cool. Nice. Cool, so this is going to update for a sec. One of the complaints people have about CDK is that deployments can be slow because our stack only has 5 resources in it, right? And we're waiting a good while here. There are arguments you can. So there's a reason it's slow. It's doing a lot under the hood to make sure it like does these changes safely, and also making sure that if things go wrong, it can roll back. But we can disable some of those protections during development to speed this up. So I may do that here in a sec. Cool. Let's go to our Lambda functions. Go here. Okay, only our code is in the code editor, and now we can see the code editor again. And do we have a layer? Yes, we do. Its compatible runtime is 3.11, and it supposedly has FastAPI in it. So in our handler, let's import the FastAPI library and see if this crashes. Because this is the test to see if we actually install this successfully. It works. Totally works. We can import FastAPI. So nice. We have a Lambda that has dependencies in it. That's sick. All right, how much time we got? We got 6 minutes. We can start writing our API. Let's do a FastAPI app with an on-startup event that fetches our thing from S3. I bet we can. Also, this would also be a good time to take questions too. Oh man, why are you waving your hand in chat? What does this mean? Nice. All right, so let's see if we can get an object into our S3 bucket and download that object on startup with our FastAPI app. So I'll just upload the raw JSON files of my LinkedIn posts, actually. That would be a decent thing to do. Posts.json. I have it on my other screen, you can't see it. Okay, cool. So here, got an object here. Can I just drag and drop this thing? What? Wow, for once in AWS's life, the UI is good. Okay, cool. Yeah, that, upload. Sick, post.json in. We now have my posts, which if we look, can we look at this? Can we open it? Yeah, nice. See, look, it's all my LinkedIn posts ever as JSON. All right, cool. Let's see if I can download those from the, oh, you know what? Actually, let's not do FastAPI stuff. Let's do permission stuff because it's not going to work right now. Photo 3 comes pre-installed in here. Yeah, can I do this in the next 4 minutes? Possibly. I want to make it so that our function accepts an environment variable containing the name of the S3 bucket, and then our function tries to reach out and download the thing. But in order to do that, our function is going to have an IAM role that grants it read access to our bucket. There's a few things we're going to have to do. So one of the things I love about CDK is it makes a lot of working with permissions like extremely easy, I find. So I'm storing our bucket in our function. Watch this. I can just do bucket.grant to fn, or maybe not, maybe it's not quite that. Bucket.grant read write. So good. And then our function has a role on it, right? Does it? Yep. Nice. So theoretically, this one line of code updates the IAM role for our bucket, and now for our function, now our function can read write from the bucket. If this works, if it's that simple, that is so nice. Okay, and then the other thing we need to do is I'm going to pass an environment variable to our function. Man, I really hope that this is right. Environment. Sometimes, yeah, autocompletion seems to be hit or miss here, but yeah, bucket name. Check it out. Key value pairs, creating a bucket, passing in the bucket name. When the CDK code runs, this is not the actual bucket name. This is just a placeholder. It's weird. You generate JSON first, and then the bucket gets created, and this gets passed in later. So when this code actually runs, it's just a placeholder. But when the Lambda function runs, this will actually have the bucket name there. Now in the handler, import OS, bucket name equals that. And then let's see if on startup we can just fetch the JSON thing from this bucket. Post JSON path equals, oh my stars, that was perfect. All right, let's see. So import Bodo, use the resource API to fetch the post JSON file. Nice. Yeah, that should all be good. We're not getting auto-completion. There's ways we could fix that, but we don't have time in the next 2 minutes. Cool. So let's read it as a string and print it. Okay. Let's see what this does for us. So I just made all these code changes both to the infrastructure, the CDK code, and to the app here. So all of that should be updated now when I run CDK deploy. And this is where a nice infrastructure as code tool starts to get really good. The development iterations can go, oh, I told you I'd do. So I think if we do the hot swap feature, there's a flag called hot swap. I think this should make this deploy might be slow, but I think it'll make future deploys a little faster. We should deploy these changes. Nice. Okay, so here's the diff. Basically, you can see it's changing our IAM statement. It's allowing for all these actions. It's granting our Lambda function role all these actions on this resource, which is our bucket. That's so sick. All right. Yes. Okay, cool. The following non-hot swappable changes were found to reconcile these. Darn, I guess Lambda layers don't support hot swaps. That sucks. Okay, cool. Let's refresh our view here. To leave and come back. Okay, we're technically at time. Can we do this? Your code has been updated. Yes. Okay, there's our code. Test it. Say invoke it. Access denied. What? No way. I can't stop. I gotta stay on and finish this even though we're at time. Okay, go to permissions. Doesn't seem like our Lambda function has many permissions. I wonder if it's just gonna take a while to update. Let's go to the role name here. Got one policy on there. Oh, did the deploy fail or something because of hot swap? I don't know. I don't think that's the reason, but I'm just gonna rerun it just in case. Oh yeah, seems like the changes didn't actually go through, so the hot swap must have messed it up. This is where serverless stack is really nice because serverless stack can just do like these hot reloads. Save your file, Lambda's instantly updated. When they do that, but I think secretly the Lambda's running on your laptop or something and they're like proxying API gateway to your laptop. I'm not sure, but it's a pretty slick experience. This iteration cycle time is not incredible. But one nice thing is if we change the Python packages that we're wanting to install, this will always make sure those get updated. So it's hard to, maybe there's a fancier way to go about this to make these deployments a little faster. Because yeah, that was 54 seconds. That's bad. And that's just for one Lambda. Imagine if it were more. All right, so get our function, refresh. Actually, yeah. Hey, S3 is here now, and we have all these permissions for S3. All right. That oughta. Oh, yeah. Oh, wait. I lost it. Sorry. Test. Invoke. Look, all in one line. There's all my LinkedIn posts that are printed out. Nice. Cool. So I think this is great. So on a future live stream, we can put some basic FastAPI code in here, and that's going to be really fast. And so I think the next session here would be like actually working with LanceDB to vectorize and make the LinkedIn posts and all that content searchable. So yeah, let's see. Anything in the chat before we wrap up? Also, if anyone is on, oh yeah, we'll have to jump. If anyone's on, if you have questions on anything, like it doesn't have to be about what we recorded here. So I'll hang out for a little bit. You can fire them off if anyone's there. Thanks, Amit. Yeah, not the developer experience I was hoping for. I mean, it is really nice that we can wrap all this stuff in CDK. Like it is really great that we can do all this in one CDK deploy command. But the deploys are slow, and the auto completion for CDK is a bit spotty. And I think the reason why is because CDK is such a giant library. It's hard for it's hard for VS Code to like index it properly. But yeah, we have this handler and we have our slick requirements txt and our tooling, our tool chain for like generating this guy. And oh, you know what I should have done? I should have pushed this Git repo to GitHub. Maybe it's already in GitHub. Do I have a diff of just what we did today? Probably not, honestly. No, I don't. So that'd be really cool if I could do like a single commit or a PR that just had what we did in this one live stream. Cool. Let's close it out. And I'm going to put out feelers and see if people are interested in the vector part. I'm actually guessing that more people are going to be interested in the vectorization and full text search than the infrastructure. But I don't know. So if there's interest in that, then we'll do another session, do more Q&A, get our full text search API actually working. Anyway, so let's close the live stream and thanks for joining.